This is Dr. Naga Anjaneya Prasad, Assistant Professor, Department of Chemistry. Today, I am going to discussing about electrochemical corrosion. What is electrochemical corrosion and what is the mechanism for electrochemical corrosion? So, in previous class, we have discussed about what is a corrosion and what is a chemical corrosion. And corrosion is nothing but destruction of material or decay of material by the attack of foreign substances. So, depends on condition of a reaction. Here, two types of theories is available to explain the mechanism of corrosion. That is electrochemical corrosion and chemical corrosion. So, in previous class, already we have discussed about chemical corrosion. So, let us discuss about wet corrosion or electrochemical corrosion. So, that means how we can define wet corrosion. So, destruction or decay of material takes place in presence of moisture. That means wet conditions. So, conditions of the reaction should be wet. So, destruction of the material takes place in presence of wet conditions are nothing but electrochemical corrosion or wet corrosion. Here, wet corrosion takes place under the following conditions. That is, when two dissimilar metals are alloys. When these two dissimilar metals or alloys contact with each other in presence of aqueous solution or moisture. When matter is exposed to the various concentrations of the oxygen or electrolyte. Okay, so first condition is two dissimilar metals which are contact with each other in presence of electrolyte. So two dissimilar metals are nothing but depends their reactivity. So depends on reactivity. Two dissimilar metals are contact with each other in presence of moisture as a electrolyte. Moisture as a electrolyte. So if you see this possibility of electrochemical corrosion, it is a look like construction of electrochemical cell. So in electrochemical cell constructed by two different metals which are connected with each other, and out of these two metals, one metal acts as a anode and one metal acts as a cathode. These two metals are dipped in some solution which is act as a electrolyte. So here also in electrochemical corrosion process also, this is one possibility. That's the two dissimilar metals which are contact with each other, and these two metals are pressed or dipped in a moisture that is act as a electrolyte. So that's why we can call it is wet corrosion is also known as electrochemical corrosion. So the mechanism of destruction of metal in presence of moisture, it is look like a electrochemical cell. That's why we can call it is the nothing but electrochemical corrosion. And if you see the second possibility, That is, when matter is exposed to various concentrations of the oxygen. That means, suppose if you take, let us consider some metal, so which is exposed to different concentrations of the metal. So let us consider the half part of the matter is exposed to oxygen and half part of the matter is not exposing to the oxygen. So same matter which is present in different concentrations of the oxygen. So in this condition, the part of the matter which is more exposed to the oxygen act as a anode, and rest of the part of the matter act as a cathode. So this part of the matter is more exposed to the oxygen. That's why oxidation takes place. That's why we can call it is the part of the matter which is more exposed to the oxygen act as a anode. The part of the matter which is less exposed to the oxygen act as a cathode. Here oxygen act as a electrolyte, nothing but. So here also anode and cathode and electrolyte. These anode and cathode are contact to each other. So that's why we can call it is electrochemical corrosion. So in this possibility also the type of mechanism is look like a electrochemical cell. So that's why we can call it is wet corrosion is also known as electrochemical corrosion. So let us see the mechanism. Electrochemical corrosion involves flow of electron current between anode and cathode areas. So one part of the matter becomes a anode and flow of electron current between the anode and cathode areas takes place through a electrolyte in contact with it. The anodic reaction involves the dissolution of matter to metallic ions. That means, so at anode oxidation reaction takes place as we know. So what will happen when oxidation reaction takes place? Matter convert into metal ion by the liberation of electrons. Hence, corrosion always takes place at anodic area. So why? Because we know that corrosion is nothing but oxidation process. So where oxidation takes place, at cathode or anode? At the anode, oxidation takes place. So due to the oxidation at the anode, matter convert into metallic ion. So look at this. So at the anode, so oxidation takes place. So matter undergoes oxidation by the liberation of electrons. Matter convert into metallic ion. Where in cathodic part, direction takes place. So that means whatever electrons liberated at anode, that electrons are moved towards cathode. There, by the gain of these electrons, direction reaction takes place at cathode. So this direction reaction depends on corrosive environments. The direction reaction takes place at corrosion environments. So if it is acidic environment, the cathodic reaction is different. If the corrosive environment is basic, the cathodic reaction is also different. So let us see the mechanism. Evolution of hydrogen. So depends on corrosive environment. Direction reactions are two types, that is evolution of hydrogen and absorption of oxygen. So oxidation reaction is same. Oxidation reaction is same at different conditions of the corrosive environment. In both conditions, that is, if the corrosive environment is acidic or corrosive environment is basic, but anodic reaction is same, that is the oxidation. Only cathodic reaction is differs. So that cathodic reaction which is depends on nature of corrosive environment. So if it is corrosive environment is acidic, then evolution of hydrogen reaction takes place. If corrosive environment is basic or neutral, absorption of oxygen mechanism will be takes place. So let us see what is the evolution of hydrogen and what is the absorption of oxygen. So in acidic medium, cathodic reaction takes place by the evolution of hydrogen. So evolution of hydrogen means removal of hydrogen gas. So consider the corrosion of iron. The anodic reaction is dissolution of Fe as a Fe+2 ions with the liberation of electrons. So if you see that at anodic part, same reaction. So metal undergoes oxidation, forms metal ion by the liberation of electrons. So here let us consider iron, corrosion of iron. So in place of metal, I am going to take iron. So iron, by the attack of oxygen, it converts into Fe+2 ions. So by the liberation of 2 electrons. So look at here. So iron undergoes oxidation and converted into Fe+2 ion by the liberation of electrons. This reaction is same. Oxidation reaction is same at both conditions, at acidic medium or basic medium or neutral medium. Anodic reaction is same, as I told you already. Anodic reaction is same in both conditions, but cathodic reaction will be different. Now these electrons, that means whatever electrons formed due to the oxidation of iron, the 2 electrons are liberated. These 2 electrons are flow through the metal from anode to cathode, where these electrons are taken by H+ ions present in the acidic solution. Acidic solution. That means already we know that this evolution of hydrogen takes place at acidic corrosive environment. So whatever electrons releases due to the oxidation at the anode, that electrons are taken by H+ ions present in the acidic solution. Look at here. So 2 H+, 2 electrons forms H2. So by the gain of H+ ion, by the taking electrons, 2 electrons which are coming from anode forms H2. That is evolution of hydrogen. Okay. So whatever electrons which are formed at anode, that electrons are moves towards cathode. That cathode which is present at acidic medium. That means that electrons are reacted by hydrogen present in the acidic medium condition forms hydrogen gas. So that is the evolution of hydrogen. Next one is absorption of oxygen. So this type of mechanism we can observe. The cathode present in the condition of present in the neutral or slightly alkaline medium. So neutral or alkaline medium, cathodic reaction takes place with the absorption of atmospheric oxygen. That means cathode should be present at neutral or basic medium. So in these types, the electrons liberated from iron, that means at the anode. Here also same reaction, anodic reaction. Already as I told you, the anodic reaction is same, that is oxidation in both conditions. First step is oxidation reaction. So iron undergoes oxidation, Fe convert into Fe plus 2 ion by the liberation of electrons. So in this condition also, same reaction we can observe at the anode, that is oxidation reaction. So whatever electrons which are formed at anode flows towards cathode. These electrons are received by oxygen, dissolved forming OH minus ions. Okay. You can see here oxygen which is present in environment. That environment should be neutral. That means water molecule is the neutral. So these electrons are coming from anode. By taking these electrons, oxygen present in the neutral environment forms hydroxide ion. Here also gaining of electron takes place. That's why we can call it is reduction. So this type of cathodic reaction is possible at neutral or basic cathodic environment. Look at here, absorption of oxygen mechanism. So suppose if you take this is a metal which is present in neutral medium, that is H2O neutral medium. So oxygen present in the environment. So in this condition, the metal undergoes oxidation, gives electrons. These electrons are moved towards cathode. Here cathode is nothing but environment. Here what is a cathode? Here anode is metal, cathode is environment. That environment should be neutral. So what happened during neutral of the environment? Reaction during neutral environment, oxidation reaction is same. So oxidation takes place at metal surface. That metal converts into metal ion by the liberation of electrons. So these electrons are moved towards cathode. Their cathode is present in neutral medium. So that is the absorption of oxygen type of mechanism. And next one, these liberated electrons, ions at anode, OH minus ions at the cathode diffuses and come into the form first corrosion product, namely that is ferrous hydroxide. So Fe plus, it is formed due to the oxidation at the anode. OH minus, which is formed at cathode, there that cathode should be neutral or basic condition. These two ions diffuse towards each other, forms FeOH2 as a corrosive product. In the presence of excess of oxygen, FeOH2 is changed into FeOH3 with composition of Fe plus 3 to O3 to H2O. So it is known as rust. So that's why we can take it as an example for wet corrosion. So rusting of iron is we should consider example for corrosion, wet corrosion. Similarly, evolution of hydrogen. So when evolution of hydrogen mechanism takes place, cathodic environment should be acidic. Here also, suppose if you take this is a metal, surface of the metal. So oxidation reaction is same. So during oxidation reaction, metal undergoes oxidation. Metal convert into metal ion by the liberation of electrons. So these electrons moves towards cathode. Here cathode is present in acidic condition. Here what is cathode? Environment is the cathode. Matter is the anode. So oxidation takes place at metal and releases electrons. These electrons moves towards cathode. Here cathode is the environment. That should be acidic in nature. That's why I'm indicating with HCl. This is the environment. That should be acidic. This should be act as a cathode. So this is the metal. It should be act as a anode. So oxidation takes place at anode. So metal convert into metal ion by the liberation of electrons. So these electrons moves towards cathode. So forms hydrogen gas. So all the metals above the hydrogen in electrochemical series have a tendency to get dissolved in acidic solution with simultaneously evolution of hydrogen gas. So from the electrochemical series, we know that those metals which are placed above the hydrogen has higher tendency to get dissolved in acidic solution with the simultaneously evolution of hydrogen gas. So that is the evolution of hydrogen type of mechanism. So when iron, for example, when iron metal contact with non-oxidation agents like HCl and hydrogen, evolution occurs. So at anode, same reaction. At anode, oxidation takes place. So that is if you take iron metal. So iron metal undergoes oxidation. Iron convert into Fe plus 2 ion by the liberation of electrons. So these electrons are moved towards cathode. So these electrons are moved towards cathode. Their cathode should be present at acidic medium. That means it should be reacted with hydrogen, forms hydrogen gas. So H plus reduced to hydrogen gas by the taking of electrons which are coming from anode. Here anode is nothing but metal. When iron metal contact with neutral solution of an electrolyte, in presence of oxygen, OH ions are formed. Iron dissolves as a Fe plus 2 with the liberation of electrons. So in neutral medium. So here I am going to see the mechanism in presence of neutral medium. So in both is neutral medium and acidic medium. Oxidation reaction is same. Where oxidation reaction takes place at anode. So here also same. So at anode what happened? Metal, that is iron, convert into iron plus 2 ion by the liberation of 2 electrons. So oxidation reaction takes place. So these electrons are moved towards cathode. So let us see. These liberated electrons flow from anode to cathode through metal where the electrons are taken by the dissolved oxygen to form oxide ions. So metal ion at anode and hydroxide ions at cathode diffuse towards forms FeOH2. So that is the resting of iron. So if enough oxygen is present, FeOH2 easily oxidized to FeOH3 and Fe2O3H2O, that is rest. So it is possible when excess of oxygen present in the environment. Okay, so that is about electrochemical corrosion. So what is electrochemical corrosion? Degradation or decay of metal in presence of wet condition, that means moisture. So in both cases, oxidation reaction is same at anode, but cathodic reaction should be differ. Depends on environment. If the environment condition is acidic, then evolution of hydrogen mechanism takes place. If the environment is basic or neutral medium, absorption of oxygen type of mechanism takes place. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.